Okay, I picked up this really nice little chassis. You know, I've had it probably about 6 months, or maybe a year or so, and you know, it looks like somebody was getting ready to make an amplifier out of it, but just never finished the project. Here, you know, this probably was from an organ or something. You know, that's all I can think of is what this originally was from. But you know, it has tube sockets. It has 6 octal tube sockets. Originally, it had a 5U4, 2 6L6s, and 6L7, 6SL7, 6SQ7, a 6V6, and then this, I think it's a 6J7. I'm looking upside down here, but that like deep socket, I'm not sure what that's for. Maybe it was a really tall tube, or maybe they had something here that they needed to sink that down for some reason. It's got 3 pots already in it, power switch, and this other power switch up here. And then underneath, you know, there's nothing's wired up. I checked the transformers, and they're good. One set of wires on the power transformer was mislabeled, but I have identified those. And so I was trying to think of some kind of amplifier I could build out of this. You know, it doesn't have to be the same exact tubes as they're listed here, but I was just looking through some schematics to see if there was something that I could use this chassis for. So I was looking at this Bassman amp schematic. I think this is the original Bassman schematic, and you know, it's got a 5U4 and a 2 6L6s and the phase inverter, and then it's just got these 2, you know, parallel single stage input tubes. So I was thinking I would like to have more gain than that, so this is a subsequent Bassman amp schematic that has 12 AY7s and 12 AX7s in the preamp stage, and they're, you know, dual stage, so you would get more gain. And this schematic is what the original Marshall amplifiers were based upon. So I thought that'd be pretty cool to make a kind of like a little Marshall out of this thing. It's got a rectifier tube. It's got a GZ34 here, but that'd be fine. And then 5881, you know, 6L6, so something like this would probably work. The only thing is I want to use my beautiful octal tube sockets, so I was searching to see if there was some kind of a alternative to a 12AX7 that would use an octal socket. And I was looking at my receiving tube manual, which is falling apart. I got this RCA receiving tube manual, and of course all the stuff's online, but it's just a lot more fun to just look it up on a book like this. On a 12AX7, there is a octal equivalent, not a similar tube with characteristics similar to a 12AX7. This is a 6SL7 GT. So then if you look at the 6SL7 in the, I got this really cool essential tube characteristics GE. I wonder what year this is from. Probably the 60s or something. I don't know. But anyway, if you look up the 6SL7, the amplification factor is 70. And on the 12AX7, the amplification factor is 100. So it has a little bit less gain. But what I was thinking I could do on the schematic, you know, this Bassman has two parallel inputs. You got the bright channel and then the normal channel. Each one uses one side of the 12AY7 in this case, and they're parallel. So what I was thinking about doing is, I don't need all these inputs. I think the only difference also is just this 1.0001 cap. If you look at those two channels, they're parallel, and the only difference, looks like to me, is that one cap. So I was thinking about just simplifying this to one input and then make a switch so where I could switch that's basically a tone, the bright cap, switch it in and out, and then put these two stages in series instead of parallel like this, like it's shown here. So it'd be two stages before the second tube, and then the second tube, you get one gain stage, and then that comes off the cathode. So I don't think that's gain. I think that's something that does something with the impedance. So if we did that, we'd have three gain stages. Then this fourth section of the tube, which changes the impedance for the tone stack, and then you've got the phase inverter tube, which would provide a little bit more gain. So basically, we'd have four stages of gain before the output tubes. And then I would use the 5881 is the same as a 6L6 essentially. There's also the Marshall, which is based upon, it's almost identical circuit. It uses EL34s, which I think have a little bit more gain. I could be wrong about that, but anyway, I'm going to start with the schematic and then see how we end up. Basically, just putting the first stage in series and using the 6L6s. This thing's got a power switch here. I think I'm going to move this power switch, over here by the transformers where all the power is, and then put some kind of indicator light here, and then put the input jack here instead. I think that makes more sense, because otherwise you'd have to run power all the way across the chassis over to here, so that would not be a good thing. So I'm going to put the power switch here, I think. Okay, I'm getting going on this amplifier. I've got the power switch and the pilot light and also the input jack, and I've got a switch there to switch in and out different resistors on the input. Right now I've got a 68K and a 20K in there, so there'll be like basically a high and a low input, and it'll be switchable with this switch right here. Also, I've got the jack for the speaker, and you know what, I'm going to need a switch to switch between 4 ohms and 8 ohms, so I've got to add that. And then also got some fuse holder, and then a hole for the power cord to come through. On the front I'm going to need to add I've got volume, low, and mid, and I've got to add a treble and master volume. Master volume's not on the schematic, but I'm going to add it. It'll go right after that, the tone control, like right about there, I think, is where the master volume goes before it gets to the phase inverter. These schematics, there's this website, Rob Robinette. If you're going to build one of these, you should check that out. I've never seen this stuff before, but it is great. He's got like the voltages and things on the schematic, which is going to be very helpful. So yeah, that's going to be great. It's great. He's got a great website. All kinds of mods, all kinds of Bassman mods, and that's as far as I've gotten at this point. I think he's got all kinds of other amps modifications too. So you should check that out if you're going to build one of these things. Anyway, it's kind of bare at this point, but I used some shielded cable to come over to the first grid of the first preamp tube there. So just getting going. He's got the layouts also on this website, and I debated whether or not to put in a turret board like this, but this thing is so shallow and it's kind of tight. There's really not room for it. So I think what I'm going to do is, it's got several of these. There are a couple of terminal strips already in here. I think I'm just going to add another one there and maybe another one down here if I need to, and then I'll have enough terminals to make all the connections that I need to without putting in a turret board. So it's kind of interesting. This looks like the original, like the technicians that were originally building this thing. I don't know if that's their last 4 digits of their social security number or if that's their employee number or something like that, but it looks like they were signing off on something, and then RS or RJ signed off on it when it was done, it looks like. So that's kind of interesting. I'm just going to leave that in there. It's kind of cool. Okay, moving right along with this amplifier project. I started with the input. I think I might have talked about this already. I started with the input, wiring the input preamp tubes, and I got to a certain point and it's like I'm going to need some leads from the power supply pretty quickly here. So I decided to go ahead and wire up the power supply, which is this down here. So I got that. I got them all wired up. I got the power transformer wired in, and then also the output transformer. And I was undecided as to whether or not it was going to be 6L6s or 5881s as the schematic shows, or the EL34s like it's on the Plexi, the Marshall Plexi. So as I was testing the output transformer, after doing that, I decided on the 6L6 is a better match for the output transformer. The 6L6 GC is the better match for the output transformer. And here's why. I'm just demonstrating here. This is what I did. Apply 10 volts to the output leads of the output transformer. So I got 10 volts there. And then the plate leads, it's 262 volts. So basically it's a 26 to 1 winding ratio. I got 10 volts applied to the leads, and then the output, the plate leads are 262 volts. So it's 26 to 1 winding ratio. And then you square that, and that gives you your impedance ratio. And then you look up in the tube manual the recommended plate resistance for the particular tube. So for example, a 606 GC running 450 volts with 350 volts on the control grid gives you 8.74 ohms. And then the same thing, 6L6 GC with 450 volts on the plate and 400 volts on the control grid, the ideal plate resistance is 5,000, and that gives you about 8 ohms. It's ideal for 8 ohm speaker. So that's this plate resistance just comes from the tube manual. Here's a page from the tube manual. This is a RCA tube manual, and that comes from the power amplifier, push-pull amplifier, class AB for 6L6GC, 450 volts at 350 and 450, or 350 and 400 on the control grid. Down here at effective load resistance, that's where those numbers came from right there, the 5600 and the 6000 plate resistance. I mean, it says load resistance. Maybe my heading might not quite be that accurate, but effective load resistance plate to plate for 450 with 400 on the control grid is 5600. And I actually, after I wired in this power transformer, I actually put in a 5U4 in there and applied power to it, and I was getting about 450 volts. So that's why it seems like it's ideal for a 6L6. I just made a little spreadsheet on Google here. If you plug that plate resistance into the formula, you get about just a little over 8 ohms. So, I mean, you can see that the EL34 came to about 5 ohms, and the just a regular 606 could work also, looks like. So that's why I have decided on the 606 as opposed to the EL34. It just seemed like this output transformer was more suited to the 6L6, and that makes sense. I mean, I bought this thing. It looks like somebody was starting a project and just didn't finish it, and they had put this output transformer on there, and the tube sockets are labeled 6L6, so that's what I'm going to go with. Anyway, that's that. I was going to try to do it without turret boards. I mentioned earlier I was going to try to make this without turret boards, but I was just having all kinds of debates in my head about how to put the capacitors in under here, twist them around and whatever. I've really come to the conclusion that the best way to do this is just put them on a turret board on the top, and that's what I'm going to do. This is going to actually, the leads are going to run through that hole right there, either through that hole, or I may take out this tube socket right here and run them through that. The turret board with these capacitors is actually going to be right above that hole right there, so probably either run it through that hole. I may take that tube socket out, or just run them across the chassis to this hole, and then to the, because they're going to go to all these, the power supply B plus leads are going to come to all these tubes, so it may make sense just to go from that hole over, but I'm not decided on that yet. And then I've got all these connections for the phase inverter and the leads going up to the output tubes. So I'm going to put in this area right here, I'm going to put one of these style turret boards, or I guess it's more like a terminal strip board, and make all these connections for the tone stack and the phase inverter connections and then the connections to the output tubes on that turret board. Kind of clean that, because that could get kind of messy underneath there. So that's the plan at this point. And then, as I've been waiting for parts to arrive, I've been sort of tinkering around with the control panel, the faceplate, and I've got this. Basically got a piece of plexiglass, real thin plexiglass, and I just taped it. I taped it to the chassis, and then my Uncle Leroy had the brilliant idea, instead of drilling the holes, just stick a soldering iron through the holes where the holes are in the chassis. So that worked out really, really nicely, thanks to Leroy. So I am kind of messing around with that. This is just the plexiglass, and it's painted gold. And I'm going to use some letters that I cut from a Cricut machine and apply to this. That's the plan at this point. I've been messing around, kind of testing it. Here, this is how it's going to look, similar to this. I don't like these letters because they're a little bit too spindly, and they kind of got disoriented or disfigured a little bit. So I'm probably going to switch to a more bold font, something like that, so the letters will not distort like they did. I don't know if you can see that. Like, for example, the top of that E is kind of distorted there a little bit, and that's just because the process of printing them, or not printing, but cutting and then transferring them over, just got a little bit distorted. This is one way to do it. This is the painted, and then I applied the letters to the paint. And then this is another way. The letters are actually inverted and applied to the clear plexiglass from the back, and then you paint the back, and that's a really, really nice looking. That's really nice looking. I mean, obviously I would paint it thicker paint, but the letters kind of got distorted because of the just the spindly font that I used. But I'm still debating whether or not to use the plexiglass faceplates that I already been painted, or just go ahead and make some new ones and do it the inverted way. That actually looks pretty nice. But I may, for this one, just go ahead and do this method where I paint and then apply the letters to the paint. So anyway, that's where it stands right now. Got a load of parts in here yesterday, so I'll hopefully start making some progress on this thing. This is how this Fender Bassman / Marshall Plexi is looking at this point. I think I've got everything wired in there. And it looks pretty good. There's a couple things I don't really like that I did, like that right there. At that point, I didn't really have a terminal board in there, and I just kind of hooked that together. But I think it's going to be fine. It's not going to go anywhere. I've got to put some kind of this is the bias pot. I've got to secure that down somehow. And also I've got the power cord restraint I've got to put on there still. I'm just going to get a zip tie and put around that and keep that from sliding around. I put in a virtual center tap on the 6-volt winding. There's no center tap like the schematic shows a center tap on the 6-volt winding. And I guess there's some debate whether or not that's really needed. I went ahead and put it on there, and I'm just now looking. There's this one lead that's tied off on the power transformer. I just wonder if that was what that was. Well, too late now. I guess it's not too late. I could always check that at some point and see. But there is a lead that's tied off on the power transformer that could possibly be the 6-volt center tap. So we'll see how it sounds hum wise. One of the last things I did was the 6-volt windings, and I did that last and above, just kind of came out above, and it just seemed like that was the simplest way and the easiest way without having the wires in the way while putting all the components on the tube sockets. Like, for example, this phase inverter is pretty crowded. You know, I was trying not to use a turret board, but I ended up using it for the this is basically the tone stack. No, the bias network, and part of the tone stack, and everything else is just on a couple of terminal strips. They were already on this chassis, so that worked out pretty good. I've just been going through and just kind of fixing things that could potentially be problems, like this right here. Originally there wasn't heat shrink on that, and I thought maybe at some point that could get twisted and short out there, so I put that on there. I've just been trying to go through here and identify potential problems. You know, this thing's not going to be on the road with Van Halen or anything like that, so it's probably not going to be too big a deal. But certain things, like I put some electrical, actually I used Gorilla Tape on the back of this right here in case those pots ever get twisted, they won't short out against that right there. There's actually something that's insulating against shorting out right there along that lip right there. I did put a couple of different choices for the grid stopper resistor on the input, and then also the feedback on the feedback resistor. I switched it so you can, there's two different values, or you can, in the center it's off. It's just completely no feedback resistor, or no feedback. So, you know, I thought it was brilliant when I did that, and then I went online and looked at some other people have that, so I sort of reinvented the wheel here on that, but we'll see how that works. I think it turned out pretty good so far, you know, assuming it works. I haven't even plugged it in yet. I've got a rectifier tube in it. I'm going to plug it in and just see what the voltages are coming out to be, and see if there's any adjustments I need to make to these voltage dropping resistors. I used the same values that they've got shown here in this schematic. This is the Bassman 5F6A schematic that's been drawn by Rob Robinette. He's got some great stuff on his website. Here's how I did this is where the feedback resistor is. I talked about that a minute ago. I also put in a master volume, which that's a horrible representation, but that's where I put the pot for that, right after the tone stack. This is where the filter capacitors ended up on the top. You know, I was contemplating at first trying to fit all this underneath, and it was going to be way too crowded, so I ran some leads up here to the top and put the filter capacitors up here on a board. And then I've got the presence control. I mean, there's not really room. The way these controls were spaced out, there really wasn't really room for a presence control on the front, so I stuck that on top there. And if you remember, there was a big old huge knob originally when I found this chassis, so that's where that is. So I'm going to try to fire it up. I'm going to plug it in and just test the voltages and just see if it's, see if there's any smoke first of all, and then see if the voltages seem like what they should be, and then we'll kind of go from there. Okay, I'm just bringing this thing up on my Variac, and I've got it plugged into my current limiter, so in case anything goes horribly wrong, it should catch it. I've got 50 volts applied at this point. Things are starting to light up here. Okay, this is the point coming out of the 5-volt windings, high voltage, just before the filter choke, and according to this, it should be about 432. I've only got 50 volts applied, so we're at 236. So let's go up here a little bit more and see what happens. About 100 volts. The pilot lamp is lighting up, and I'm at 470. Ooh, wow, this seems a lot higher than it should be. Yeah, I'm not sure what to do about that, except maybe some kind of a dropping resistor before it gets to that point. Wow. Let's see what it is after the filter choke. It says 430 after the choke. Let's see what that says. Okay, I've got it on the spot after the filter choke. I still got 100 volts, a little bit over 100 volts coming in, and I'm at 480. I'm at 480 there, and on this schematic it's got 430. On this schematic it's showing 430 there. So I'm pretty high. It's going to be really high once I apply all the power. Let's see what it is after this 4700 dropping resistor. This is saying 385. Let's see what we've got. Alright, I've put the tubes. I went ahead and put the tubes in. Got 120 volts plugged into it, and let's turn it on. Okay, so I've got it plugged in, powered up, and at this point here, B1, which is coming right off of the rectifier tube, it shows 432 on the schematic, and then at this point B1 I've got 405, so a little low, but on the schematic it says that the values could be plus or minus 20%, so I think I'm okay there. Maybe a little low, but I'm okay. And then at point B2, which is just after the choke, I've got 403, so a little bit lower, and it's lower than this value, 430, but still within the 20%, so I think I'm okay there, just a little lower than point B1. And then after the dropping resistor at B plus 3, the schematic's got 385, and $354, so quite a bit lower, but still within the 20%. And then after the 10K dropping resistor at point B, the B plus 4 point, schematic's got 325, and that's up here. and 272. So that's quite a bit lower. 325 and 272. But I mean, still within the 20%, but quite a bit lower than the others. The others were maybe 10% lower. This one's more in the range of 20% lower. So maybe we may have to change this value of this drop-in resistor here. We'll have to see how it goes. All right. Okay, there's definitely some issues with some of the voltages, and I plugged it in. I'm injecting a signal into it. I got a speaker plugged into it. I mean, you can hear some hum. I don't know if you can hear that or not, but you can hear some hum. You cannot hear this. You cannot hear the signal that I'm injecting. But listen to this. If I turn it off, when I turn on my signal generator, listen to this. You can hear it for a second. So it seems that the signal is getting through for a second, and then it's getting cut off, almost like the feedback. Maybe, let's see, the feedback is off right now. Have it off. So, I'm just going to try to inject a signal. Definitely sounds like there's some hum getting through. So I just wonder if I injected a signal down here past these first tubes. The voltages are way off. They're way low on the first and second tubes. So it's like there's the resistance is too high getting the power to these tubes. So I'm gonna have to work on that. But I'm just gonna try to bypass those and see what we get here. So what's the grid? Let's see what's the grid on the. It's pin 1, isn't it? Okay. So something with this first tube is messed up. So if I go into the second tube, we're good. So it seems that the master control is doing something, the tone controls are doing a little bit, and the volume control is doing nothing. So let's see if I bypass this input resistor. No, nothing. If you go straight into V1, I can hear it. So there's something with this first tube that's going on. Because if I jump over to the second tube, were really good, and it's like the first tube is really messing it up. Oh wow. Okay, there we go. I just bypassed that first stage. The volume control works. Tone controls. Seem to be working. Master volume, not really doing much. Okay, I've got some work to do on the voltages here on this first tube. So let me check into that. If I bypass the first tube, it has got plenty of volume and the signal's getting through. And anywhere on the first tube, basically nothing, or very, very weak signal. So I think what I'm going to do at this point, remember the voltage was really low here. It was like 275, so that's quite a bit. I mean, it's even less than 20% low, right? No, I guess it's not, but pretty close to 20% low. I think what I'm going to do, I'm going to decrease the value of this dropping resistor and try to get that voltage up. Of course, it's feeding. I think I'm going to decrease the value of this, increase that. That'll increase that voltage, and then it'll increase this voltage that feeds the first tube as well, and then maybe also work on the values of these two resistors here to see if I can get the voltages up here, because I was only getting, that's 150 volts, I was getting like 7. So something's way low over here on this first tube, and I think if I do a combination of reducing that resistance there and reducing these resistances here, it'll get us what we need here to have some signal coming through this first tube. So we'll see. Well, I'm going to try that and we'll see what happens. Alright, I was thinking this through some more, and I was going to decrease the value of that dropping resistor, but I was plugged into, previously I was plugged into my current limiter. Now I just plugged the amp right straight into the wall here, so I'm looking at point B4, point B4, which is right here, and the schematic's got 325 and I'm at 319, so I think I'm going to leave this alone. Also, the voltages on the second tube will seem a lot closer, so what I'm going to do is just change the values of these load resistors and see what happens with that, because there's no signal getting through the first tube whatsoever. So I think, and the voltages are really, really low. So I think at this point I'm just going to fiddle around with these two 100K resistors and see what we come up with. I'm just going through this thing trying to track down voltages and that sort of thing. And I did notice one kind of an important wire that I had forgotten here. There's this wire that goes from the high voltage windings up to the bias network, and I completely have not got that wired in there yet. I was waiting to get this board, this terminal board in here, and do that after I put the board in there, and I just have not done that. I never did do that, so that's one thing I've got to fix. I got to add that wire. And one difference here is this transformer's got like a tap that goes up to the bias network, and you know, I don't. This one didn't have that. So what I did is I just looked at some other schematics that had a similar thing, and then they had added a resistor in there instead of having a tapped transformer. They just took it right off the lead, one of the power leads, the high voltage leads, through a 220. All right, I've got the wire to the bias in, and you know, the reason I even noticed that was because I was checking the voltages, and you know, right here where the bias goes up to the tubes, it's supposed to be 48 minus 48 volts. I was at like 400 volts positive. So then I started looking at it, and it's like immediately it's like, oh yeah, I forgot that wire. So right now it's right at, you know, 47, which it's supposed to be at 48. So we should be good there. You know, originally I said I was going to put the first and second stages of the first tube in series to get more gain. And you know, it had a lot of gain. I could not, it was like it was out of control gain. So I scrapped that idea, and I went with this, which is putting them in parallel. So I just come in here, I got a switch. You can go just through the first stage and on to the second tube, or you can flip the switch and it puts both stages of the first tube in parallel, and then comes back up here and then into the second tube, which seems to be working pretty good. It seems like it's got plenty of gain. So that's what I ended up doing. Here's the finished product. The voltages are kind of high. They're about 20% higher than what is showing here, but if you look at this notice, it says it could be plus or minus 20%. So I'm right at 20% high. I tried putting a resistor right here, which brought them down. Whoops. It brought the voltages down to what I need, but it added a lot of hum, and I could not get rid of that hum. Adding some more capacitors here, and it just didn't make any difference. So at this point I've gotten rid of this resistor, and I'm going with the higher voltages. It sounds good. So at this point, if you look at I got it plugged in, got my signal generator plugged into it, and then I'm monitoring the output with my scope. If you turn up the master, you get a pretty nice sine wave, and if you crank it up even more, some guitar through it, and it sounds fine. So I think I like it this way. I'm just gonna leave it at this point. I think I'm gonna stop with what I've got. Go ahead and get the faceplate put on it and kind of wrap things up, and then think about some of these changes. Like here on this switch, I would like to get a different switch. The switch I've got right here right now is just, I can go the first stage and it's off in the middle, and then the two stages together. So what I'd like to get is a different switch that I can go the first stage or second stage or both. So I've got to get a different switch for that. But at this point, I think I'm going to stick with what I've got and play around with it a little bit. And then also on the feedback loop, I've still got these two different resistors. It seems to make a pretty big difference. I've actually ended up with a 56K and a 150K resistor there, are off in the middle. So anyway, that's it for now. I'm going to probably check the bias on the tubes. I got some new tubes coming for it, but I'm going to go ahead and check the bias with the tubes I've got. There's some used tubes, and I'll probably do that next. While waiting for parts, I've been trying to mess around with the faceplate, and I think I've got it down here. You know, in the past on all the amps that I've built, I have just either left the controls blank, or just printed some cheesy looking things from my printer. And this time I used my Cricut machine and actually printed out some letters and stuck them on here. And basically I took a piece of plexiglass, painted it gold, printed the letters out from the Cricut, stuck them on here, and then put another clear coat over it. I'm going to go with chicken head knobs, just because, like, if you're in a dark stage, I mean, Marshall knobs and even Fender knobs, you cannot see the numbers, but with the chicken head you can tell immediately what the setting is. And I think we're going to call this thing since it's a kind of a cross between a Bassman and a Plexi, it's going to be the Plexi Man. So anyway, that's our logo for this amp. It's the Plexi Man. So anyway, that's how that turned out. I decided to try to come up with a better faceplate instead of just leaving them blank this time. So okay, I went through the bias computations, and with the pot turned all the way down, it's got a negative 49 volts, which is pretty consistent with what the circuit shows on the bias circuit here. It's got minus 48. And the plate voltage is 510, 511, and then the plate dissipation is an average of 5. So I'm not really sure what's going on with that. It's only like, average of 17.5%. So I'm not really sure about that at this point. If I turn the pot all the way up, it drops that voltage down to 39 volts, minus 39. Drops the plate voltage down to 49, 492 and 493, and then the average plate dissipation is 12. And on a 6L6, it can go up to 30. So that's an average of 41%, which seems really low. So I'm not really sure what's going on with this. The tubes I've got in there right now are used tubes, because I didn't want to take a chance on blowing my new matched set of tubes up. So that could just be the fact that those tubes are worn out. At this point, that's what this is showing. I'm not really sure about it. and I'm just holding off to put the new tubes in there until I make sure everything is good so I don't blow out a new pair of tubes. I also wanted to do some testing on a different rectifier tube. You know, the schematic has got on the B plus it's got 432 volts, and I'm showing 492, 494, probably about 493, which is a little high. So I'm going to try a different tube in there. The GZ34 I think is going to come out with more volts, but we're going to see here in a second. I'm going to just change that up. Right now I've got a 5U4 in there. It's a used one too, so we're going to see what the difference here is with the GZ34 in place of the 5U4. Okay, I've got the GZ34 in the tube socket, so we're going to see what happens here. I'm assuming it's going to be higher just because that's what I've read. And it's, yeah, I think I'm just gonna, well, it looks like it's about probably 30 watts higher, 30 volts higher, so that's going the wrong way, so I'm just not gonna, I just wanted to see what the effect of that was. So originally I had this beautiful Zenith 5U4 made in USA in the socket. So it's used. I mean, it came from an organ that was from the 60s. Oh, wait a minute. Replace only with a genuine Zenith tube. So we may be in trouble here because I'm putting I've got this JJ. Oh, wait a minute. Made in Slavic Republic. We'll have to see about that. So anyway, I've got the new JJ 5U4 in there. Let's just see what happens with it. See what happens with the voltage here. Monitoring the B plus. That's interesting. The difference between how with the GZ34, it came up gradually. With the 5U4, it was high, and now it's coming down. We're just sitting about 503. So a little bit higher. Not as high as the GZ34. Let's see what we got on the... Still have my sine wave with the rounded top. So anyway, I've got this match set of 6L6 GCs. So I'm going to put those in. This is what came out. You know, they're not marked in any way. I don't see even a tube designation or a manufacturer or anything on these things. So they came out of a Fender amp, so that's interesting. Maybe they just put these generic tubes in there, unless somebody cleaned it and just cleaned all the markings off of it. But anyway, that's what was in there. Just these generic looking, I'm assuming they're 6L6s. So yeah, with the new tubes, this is with the pot still turned all the way up and 39 volts, minus 39 volts on the bias circuit. The new tubes are 505 and 506, and the plate dissipation is coming out to 12.5, which is about what the other ones were coming out to be. which is still only 42%. So I've still got some work to do here to find out how to increase that. It seems like I would need to do something with this to make that lower so that I will get more plate dissipation. Anyway, I'm just gonna at this point just carry on and think about what to do to get this plate dissipation up. So I'm running these tubes at about 12.5 watts, it appears. I'll have to think about that some more. Okay, I've got the solid state rectifier in there. I thought I'd just go ahead and test and see what the effect of that is going to be on the voltage. I went ahead and plugged my old output tubes back in just to make sure in case something goes haywire here. So anyway, I'm still monitoring the B plus right here. So let's turn it on and see what we got. It started out at like 575, and that's dropping down. Remember the GZ34 was like 525. The original 5U4 was about 495, and then the new 5U4 is about 503. This is about 40 volts higher than that, it looks like. So I probably will not leave that in there. That's running a little bit hot, I think. I was having trouble with rectifier tube socket, and I was thinking it was the pins on the tube socket, but it turns out that I had pulled the rectifier tube out and exchanged it so many times that one of these solder joints had come loose. I just hadn't done a real good job of soldering it, I guess. So that's fixed. And then I was just checking through here, and there's a couple of other places that need a little bit of quality control. That right there, that's not going to work. And then I think there's another one up here that I'm going to hit again just to make sure that that's good. There's a little bit of static. I'm not really sure what's going on, so I'm going to clean up some of these solder connections. And also the first stage seems kind of muddy, so I think I'm going to change out that capacitor right there to something a little bit smaller. The second stage, when you kick that in, it sounds great. If you just go with just the first stage, it sounds kind of muddy, so I think it might be that capacitor right there. I'm going to use a little bit smaller value. This is a 0.2. On the second stage, it's got a 0.2. I think I'm going to do the same thing for the first stage, just to see what difference that makes. It just seems kind of dull and kind of muddy. Okay, just for fun, I'm looking at the signals coming out of the phase inverter into the power tubes on the grids of each one of the power tubes, and yes, they are 180 degrees out of phase, which is good. The signal looks good, so that looks pretty clean right there. That's coming out of the output. I'm only at about 9 o'clock, not even 9 o'clock, and the master is, way down about 8 o'clock. So anyway, I just wanted to see what the signal looked like coming out of the phase inverter. So there it is. Okay, one other thing. This resistor coming off out of the first stage into the second stage, the schematic calls for 270. I had a 470K in there based upon what's on this. This is the Marshall Plexi circuit. I had 470K there, And looking at the signal right there, the top was flat. So I'm not really sure why I need that, because I don't. This is for like balancing the two channels. It looks like. I mean, it says mixing on this thing, but I think it's for balancing the two channels. So I started to just take it out, but then I noticed that if you put a 56K in there, it looked, the signal looked great, the sine wave looked great, and it sounded good. So I put a 56K there instead. Oh, and that's this one right here that's coming off of the out of the first. Actually, it's coming off of the volume control into the first stage of the second tube. So yeah, on the schematic, it comes off the volume control into the first stage of the second tube. So at this point, I don't think I'm going to make any changes. I've got some static issues, but I think it's because I've got this thing is open, you know, right under these lights, and I got a bunch of power supplies and my computer's here, and you know, there's all kinds of sources for static. So I think I'm going to this is the bass that someone, it's really kind of beautiful, it's made out of oak, a bass that somebody made for this chassis. I think I'm going to make some kind of a shield and put and attach to that, and then mount the amp on it, and hopefully that'll get rid of some of the static. I mean, if you turn this thing on and turn the volume down, it's pretty much dead quiet. So that's good. But when you crank the master all the way up, there's a little bit of there's some static going on there. So hopefully I'll put some shielding and mount this to the bass, and that will hopefully be reduced. And we can do a little sound test here. So I just tacked in some of this disposable grill topper. I got a bunch of this at Walmart. Sometimes I use it for small amplifiers. If the grill cloth is destroyed, I'll just tack some of this stuff in there. And so I just tacked some of this on that bass. I mean, it can't hurt. It looks pretty cool, and it seems like it would shield some of the static out of there. So we'll see what happens with that. I just stapled it in there. Okay, just to check the noise floor on this thing, I've got amplifier on, and the master and preamp volumes are down. I've got my meter piggybacked onto the speaker output jack, and it's showing 6 millivolts of hum, and I mean, you can hear it above the cricket there. You can hear it. Just really, I mean, it's just barely. You have to be right up on it to hear it. But anyway, 6 millivolts of hum. That's not too bad. I don't know if I mentioned this, but I went ahead and completely redid the power supply. I was not happy with the turret board that I originally had. I had a lot of trouble soldering it, and the solder just looked like a complete hack job. So I redid this, and then I put this shield over it. This is, I think it's going to be temporary. I'm going to have more like a metal, like a standard doghouse kind of a thing here. But for now, I just wanted to make sure that nobody touched the, I mean, there's, you know, 350 volts right there on the end of that resistor. So I don't want anybody to get zapped. So yeah, my battery went out as I was talking about this. Yeah, there's 350 volts on that end of that resistor right there. So just in order to keep somebody from getting zapped, I put this shield on here. It may be just kind of a temporary thing until I figure out some other kind of a more like a standard doghouse. But that does look pretty cool. You can see the capacitors and everything. It seemed like it did help a little bit with the hum. On the previous turret board, I don't know if you saw that in the video, it was closer to this preamp tube. That's the first preamp tube. And I had some of the wires running right up next to the preamp tube, and I found that I pushed those wires back at least a half inch away from the preamp tube. It made a difference on the hum. So when I put this different turret board on here, I made sure that the wires weren't even close to that. So anyway, if I turn this back down to about 9 o'clock, I've got the highs about 2 o'clock, mids at 12 o'clock, and the lows at 2 o'clock. We'll just do a little bit of a sound check here. Okay, I've just got this on the first stage, selected the first stage, volume's halfway up on master and preamp. This is a single coil pickup I'm using right here, cranked all the way up. Actually, tell you the truth, it sounds kind of dull. If you turn the highs all the way up, it sounds better. And then if I flip the switch over to using the second and the first stage, obviously a lot more power. You might not be able to tell that in the camera, but yeah, it's a lot louder and a lot brighter. So that's with the single coil pickup. If I put it on back on the first stage only and use a double coil pickup, that sound, that crackling sound, I don't know if you can hear that or not. Every so often I've got a router, just right above this room. I think that's what's going on. There's some kind of activity on the router. Okay, this is a double coil pickup on the first stage of the preamp tube only. So that actually sounds pretty good. I'm going to flip it up to stage 1 and stage 2 of the preamp tube. And that's, dramatically louder. It's pretty loud. Got a really nice breakup. Actually sounds pretty good. I'm not going to turn it up any higher than that. I've got some people upstairs. I don't want to completely drive out of the house, but I guess you can turn to get a cleaner tone, you can turn the preamp volume way down and the master up. back on single coil. So you get some really nice, sweet, clean tones out of it. Turn the master down and crank the preamp volume up. Kind of muddy. Pretty muddy, and that's on the stage 1 with stage 2. Just the stage 1, I don't know, it just sounds it's really low. I do have some guitars that have a higher output pickup. It'd be interesting to see what they do with this lower output on the stage 1. But anyway, probably most of the time I'll stick on those 2 stages. Sounds pretty good, and I kind of like the clean tones down here. The presence control ended up here, and to tell you the truth, I really can't tell that much difference. I'm not really sure what it's supposed to do. That's it cranked all the way up. That's it cranked all the way down. So I think it probably is supposed to affect the mids more. It might be a little different. What do you think, Leroy? I may have to research that to see if there's something more that needs to be done with the presence control. As far as the negative feedback switch, it's back here. That is on the 56K resistor. It seems like it's a lot cleaner, actually. I'm on a single coil pickup right now. That's with it on 56K. That's 150K. Sounds the volume's lower and it's cleaner, which I think is what it's supposed to do. Actually, really nice clean tone. Probably I'll just, most of the time I'll play this with no negative feedback on there. That's a single coil, double coil. Okay, with the double coil, I can definitely tell a difference with the presence control. It just sounds fuller or something. It sounds more full, I think, with the presence control cranked all the way up. Is the negative feedback turned on the 56K resistor. It seemed like I put more mids in there. It actually really sounds good. That's 150K. That actually sounds great. Doesn't it, Leroy? Okay, well, anyway, that's it. That's it. Just kind of a quick run through of the tones on this thing. I think it sounds pretty good. I've still got some work to do. I'm not so sure about the static, but then I've got other amps that are staticky in this particular room. I've got, you know, a bunch of switch mode power supplies, battery chargers, and computer, and right up above a computer router. So that's probably what's contributing to all the noise. But anyway, I think overall it sounds pretty good. I will definitely be using this amp.
Yeah.
So there it is. It's a Marshall Plexi slash Fender Bassman clone. Thanks for watching.